collaborative document. There we go. Thank you for recording, Tutukile. You can export this into a PDF file, but it will always live the Etherpad, so you don't have to worry about that. And this is a very interactive and collaborative workshop that you'll say every day follows on the next. So you're going to need to be here every single day to wrap up and get your certificate of attendance on Friday as well. So I'm going to turn my screen off and start sharing my screen so we can quickly run through the housekeeping rules. Thanks, Rafilwe. She will be joining us in a little bit once load shedding has returned where she's based. We will see you around 10:30. Oh, I am so sorry. I must apologize. I would like to introduce our helpers for the day, Amy and Anne. Amy, would you like to introduce yourself?
Hi, yeah, I can keep it very brief. So I'm also a PhD student at Stellenbosch University, and yeah, this is also my my introduction to the Carpentry. So I'm excited to be here to try and help out. But yeah, just drop me a message if I can help out with anything.
Perfect. Thank you so much, Amy. Maybe you can just change your name in Zoom, just that you'll see what I did. I said Angie Trussell instructor, just help us, so anyone can just DM you if they have issues, etc. Is that okay? Perfect. Thank you so much. Anne, over to you. Can you introduce yourself? We seem to, oh, there we go.
Everyone.
Hi, Anne. Hello.
Cool. Hi, I'm Anne, and I'm also a PhD student at the Faculty of Medicine and Health Sciences. And yeah, I'm busy with the last bit of my Carpentry's instructor training. So yeah, I'm here to help. So please let me know if you need help.
Thank you so much, Anne, and you as well. Could you change your name just to help at the end so that the learners can see you are a helper? Okay. Thank you so much. Maybe I can join in with Rafael, where Anne and Amy, I joined the Carpentries back in 2017 while I was doing my postdoc. And I must say it changed my life in a sense of from computational sciences perspective. So I'm seeing a trend in Africa, and Rafael and Amy, what is the chance that this is kind of where we get involved with the Carpentries, right? Okie doke. So I'm going to stop talking nonsense now. I am going to share my screen. Oh, I am already sharing my screen. I'm not sure what I'm sharing. Can you see the Etherpad? Maybe if someone can just give me a thumbs up. It says data carpentry in green, super duper. Thank you so much. Righto. So as I already shared the link in the chat, but I'm going to do that again. We're going to be using this Etherpad, but I'm going to switch to the workshop website we will also be using today. So the workshop website is your schedule, or you can see the landing page says the dates, the time. We're going to be starting promptly 9 a.m. But there's a lot of work to be covered. We are hoping to finish before 1, but let's see. We can use a maximum up till 1 p.m. every day. The instructors, myself, Rafiwa, Gia, and Tajuddin, and helpers, Amy and Anne. Thank you so much again. You'll find some general information about the workshop. I also want to remind you this is a Carpentries event, and the Carpentries Code of Conduct applies. What does this mean, you might ask me? The Carpentries Code of Conduct says we treat each other with respect, the way we act, the way we speak, in our actions as well. If anyone feels like they have not been treated well or have been spoken ill to, please reach out to myself or to Rafilwe, or you can have a look at the Code of Conduct link I shared for you in the chat, and there's a link there to report a Code of Conduct incident. You'll see a link to the collaborative notes, which is the Etherpad I mentioned a tad earlier. I asked you to please complete the pre-workshop survey. This is so essential for us as instructors. And I'm going to tell you why, because the survey asks you, what do you expect from this workshop? And we need to know that because we are not going to teach you how to do statistics. We are not going to teach you how to do program. We are teaching you how to use a tool to do all the aforementioned. Then the schedule, you will see I already kind of alluded to that. Day 1 we are going to ask you to complete, let me quickly, those of you who haven't, please go ahead while I'm doing the introduction, complete the workshop survey. There's only 2 people who completed, so I think most of you do need to still complete that. And can I ask that we keep ourselves muted unless you want to ask something, and I'll talk about communication norms in a bit when we're done with the workshop website. So day 1, we're going to jump into the pre-workshop survey and introductions like we're doing right now. We are going to start with spreadsheets, which I will be leading, and I'm going to be handing over to Refillware. Day 2, we're going to wrap up Open Refine and start data analysis and visualization with R. That's with Refillware and Tajudeen. On day 3, we're going to continue R. That's myself and Refillware. Tajudeen and myself is going to take over on day 4, and day 5, Jia will be leading us. And we will then end the session with a post-workshop survey. Righto, and we have set up instructions. However, myself and Refillware were in the room. We had one query about Open Refine, and I'll chat to you about online instances in a bit. Before I go ahead, any questions from you in the room? Righto. If you're hearing licking, I have 3 dogs. I do apologize. This is the benefit of working from home. However, they groomed themselves more or less this time, so I apologize about that. We're back on the Etherpad. I'm going to share the link again for you in case you don't have it open as of yet, because there's only 7 people in the Etherpad and we are 19 in the room. So if you have not done so already, please open the Etherpad. We are going to start using that right now. Some housekeeping. As I mentioned, the workshop will run from 9 to 1 from Monday to Friday. And the Carpentries use a sticky method in person and online. But I do see that the nonverbal cues have not been activated in the Zoom room. So what we're going to be doing is we're going to use the stickies in the chat. So the stickies, we usually have a post-it, a red post-it and a pink post-it, or green post-it, purple post-it, whatever post-it color you have. And we say when you are completed with a task, we use a green post-it, and then you stick it onto your laptop, and then the instructors in an in-person setup could see what's going on. However, in this instance, we are online. So we are going to use done. And if we're done with activity, we'll just type that into the chat so that myself and Refillware and the helpers can see who still needs to finish before we can go on. And if you want to ask a question during a lesson, you can type it in the chat section of the Zoom. We will not be looking at the chat section in the Etherpad. So please make use of Zoom for any questions you might have. You can obviously direct message any of the 2 helpers, Anne or Amy. Thank you so much. You can also send a private message, as I mentioned, and we are going to try and take a break for 10 minutes every 50 minutes of teaching. So let's say 9:50, we will take a bit of a leg break because Zoom fatigue is a real thing. What we're going to be doing the next 5 days is high functioning cognitive abilities. So I do want us to be refreshed and not be exhausted every time. And just a tip about screen setup: if you do not have 2 screens, you can split your working screen from Zoom. We suggest that you can minimize your Zoom and your working screen, so then you have half Zoom, half spreadsheet, Open Refine R, so you can see both at once. If you don't know how to do that, reach out to myself, Refillware, Anne or Amy. However, for this part of the spreadsheet lesson at least, I will be sharing my screen a bit because there's some, not theory, but just a couple of things I want to run with you before we start with the exercise. So for any part of this week, and if you run into any trouble installing any software programs, particularly for Open Refine and RStudio, I have linked 2 online instances on line 27 and 28 of the Etherpad. And this is why I said I still only see 9 people in the Etherpad. Please can you sign on there for us, because it's very essential. All the activities will be done there. So again, back to the online instances. These are instances that will run off a browser, and you don't need a very fast bandwidth to run this. It will help you if you might have a laptop that is institutionally formatted and you can't install certain software programs. And at the end of every day, we will give feedback. So one thing we did as instructors well, and one thing that we need to work on. So we use Jamboard for that. We will do that after a fieldwork session this afternoon. You are all in the Zoom room, so I'm assuming you have the Zoom details. And other resources I kind of just wanted to add here for you is the workshop website, the Etherpad link, which we are in at the moment, and the pre-workshop survey link. Again, I want to remind us that attendees of Carpentry's events are required to follow our code of conduct, and I'll link that in line 42 again. So if you have any questions about that, you can reach out to myself or Refillware, or you can go to the link provided in line 42. Any questions before we hop into spreadsheets? I'll give you a minute or so just to take all of this information in, because it's quite a bit, right? There we go. Thank you. We're seeing some movement in the Etherpad. And you'll see that every day you need to sign up. You will see the content being covered. You don't have to follow along there. We'll be sharing a screen. We will be live coding. You don't have to make any notes on your end. We will download some data in a bit. But let's jump into the spreadsheet lesson. Righto. I'm not seeing any hands. I'm not seeing anything in the chat. Okie dokie. Right. So I want to start in saying that the 3 software packages that we are going to be discussing with you this week is going to be spreadsheets, which could be Excel, LibreOffice, or even Google spreadsheets if that's what you would like to use. And then it will follow into OpenRefine, and that will then follow into R Studio, or more commonly known as R. There's method behind the madness here. Spreadsheets are generally used to capture data, and we're going to look at the various other ways people use spreadsheets, right? And then if you work with big data, you're probably not going to use spreadsheets because you kind of mine the data on other ends, right? But let's say you have a survey or you have some observations, especially the ecology lesson works with observations. And we'll talk about the data set in a bit. But data is captured in Excel many times. And how do we kind of format and edit this? And this is going to be happening in OpenRefine. And Refillware is going to teach you how to filter that and how to make correct mistakes. And by the end, you're done with OpenRefine, which I just want to remind you, the programs we are using today is mostly open source, which means they are free to use. LibreOffice is free to use. Google Spreadsheets is free to use. Usually, if you have institutional access, then Excel might be easily accessible to you as well. OpenRefine is free to use. It runs through your browser. You'll see later this afternoon. It's actually quite cool. And then RStudio is free to use as well. So the Carpentries try and build capacity when it comes to open source, open science and programming, but also making it easily accessible to everyone. So let's start and see what we will learn in this section of the lesson today. And I generally don't want to share my screen, but I feel like there's a lot of text we're going to be looking through today. So forgive me, please, if I do a bit of chalk and talk. So in this lesson, we will look at good data entry practices. Maybe by show of hands or thumbs up, right? How many tell me that you have entered data into Excel sheets before? I definitely have. Right? How many can give me a thumbs up? How many of you have entered data into an Excel sheet before? Thanks, Peter. Pamela has. I definitely have, so I cannot lie there. Oh, Amy, you're a PhD student. I am absolutely convinced that you have entered data into an Excel sheet. Oh, Pierce, I hope I pronounced that correctly. James as well. Yasteel as well. So you're all very familiar with the practices of entering data, but let's see if I can help you maybe fine-tune that a little bit. How to avoid common formatting mistakes. Now, I must tell you that comma and a full stop and Excel has been my absolute end sometimes, but I think that's about regional use of Excel as well. Approaches for handling dates and spreadsheets, that's very interesting. Quality control, and for those of you who have captured data in Excel, this is going to be an eye-opener if you have not used this functionality before. And then exporting data from data sheets, spreadsheets. But we will not learn, I want to kind of highlight this on here, we will not learn how to do statistical analyses in spreadsheets. And I'll allude to that a bit later. However, the idea of using programming in data science is about repeating your analyses. And this is not possible in spreadsheets. So when we get started, you do not need any prior lessons, prior knowledge, apologies. You all, I assume no one reached out to me asking access to Excel, so I assume you have that. The data I want you to download is going to be here. If you have not done that already, the link is in the Excel sheet as well. Righto. So while you start downloading that data, I am going to go and we are going to hop into the introduction bit. Right. So what are we going to achieve today? We are going to, in this particular part, describe best practices for organizing data so computers can make the best use of your data set. So we are, again, saying that we're going to look at implementing the best practices, identifying and addressing common formatting mistakes, how to handle dates, basic quality control features, and then exporting data. And we're not going to talk about statistics, plotting, or writing code in spreadsheets. So why aren't we teaching you data analysis in spreadsheets? Now, I alluded to that a little bit earlier. Data analysis in spreadsheets usually requires a lot of manual work. And if you want to change a parameter or run an analysis with a new data set or with new parameters, then you're going to have to do everything by hand. And the chance for error is so much bigger, right? It's also very difficult to track or reproduce statistical or plotting analysis done in spreadsheets. And if you want to go back and ask for details or look at what you did, there's no way to follow what you have done. There's no code that you can kind of dissect in a sense. So there are many spreadsheet programs available. And since most of you might use Excel, this is what this workshop or this part of the workshop will be looking at. But you do have a free spreadsheet program. And for those of you not familiar with that, LibreOffice Calc and Google Sheets. I use Google Sheets quite often because at the Carpentries, we use the Google Suite, and it makes things quite easier for us. So we're going to go to the Etherpad at the moment. And I think what I want to do, I want to open some breakout rooms so you can get to know each other. I'm going to create those in a bit, but we are going to, oh, Angelique, you stop sharing my screen. There we go. We are going to, we're not going to do breakout rooms for this one. These is yes and no. So at the Carpentries, when we agree with something, we put a plus, right? And you'll see in the chat, I put that there. We are going to do an exercise where we're going to look at how many people have used spreadsheets in their research. And I kind of already did that exercise with you. I definitely have, so I'll put a plus there. Let me share my screen again. Apologies, everyone. There you go. You should be able to see my screen. So we are now on line 93. How many people have used spreadsheets? So if you agree, you can put a plus there. How many people have accidentally done something that made them frustrated or sad? Oh, I'm going to put a couple of pluses there because that's definitely me. Right, so let's all go to the Etherpad and add your answers in there. I'm already seeing multiple pluses, so let's give it a minute or two. Is there any of you would like to share what made you sad? Because I can definitely, but I'm not going to bore you with my voice the whole day. Amy, you put plus plus. What made you sad, or any interesting story? Sorry, I'm going to pick on you the whole day, Amy and Anne.
No, that's fine. So I had a fun error that happened with a very, very big data set with a misspelling, which I'm sure was on my own fault. But I ended up with like multiple versions of spelling of neutral, and I had to somehow fix all of that. So that, look, it turned out it wasn't so bad, but at the time it was very, very frustrating.
Absolutely. Absolutely. I remember when I was in high school, I used Excel primarily for my color-coded timetable, which I don't think that's the intended idea. And I think it was frustrated back then to work with Excel, and I didn't know how to do that. I didn't know, when you're 16, well, I'm not going to give my age away, but when you're 16 and you have to start using Excel and doing all these other funny things like adding and subtracting, and you don't know what you did in the back end, and you can't read what you did with the let's say the arguments I called up. I'm glad I kind of grew out of that phase. Righto. I'm seeing many people have used spreadsheets, probably most of the people in the room here today. And I'm sure there are many that accidentally did something wrong. Is there anyone in the room who'd like to share with us what you did accidentally wrong? You can type it in the chat as well if you don't want to unmute yourself. I think us in Africa are very, very aware of bandwidth issues. Righto. Okay. So,
Angelique?
Yeah, go ahead, James, please.
Sure. I was once working in quite a big project with a lot of collaborators, and we were processing a data set in Excel, and I was filtering the data, and I did something incorrectly, and the steps that I was applying were not applied to all of the entries that they should have been, which resulted in errors that we picked up sort of weeks or months later, which was quite a big deal and quite embarrassing.
Yeah, and the thing is, it's because it's done in Excel, you can't backtrack what the history was, kind of in a sense. Yeah.
Yeah.
Okay.
So these days I try to use R as much as possible for that kind of thing, and Excel as little as possible.
Yeah. I use Excel for my budget. That's probably, and I think there's a very strong, and hopefully I can convince you today that there's a good purpose for Excel. But I must say the data sets I use are generally downloaded into R already, so I can clean them there. But it all depends on what analysis you do. Let's say in behavioral science data, let's say a survey, that data might, if it's not captured like in a Google form or in a Question Pro or something like that, you're going to have to capture it, right? And we want to eliminate as much as possible human error. And I think, James, you just spoke about human error here. And this is kind of what this is why we run this section of the workshop. So thank you so much for sharing that. Anyone else who would like to share before we go ahead? No? Oh, Peter, go ahead.
Yeah, my story. Hi, I'm Peter, guys, from South Africa here in Limpopo. So my story with Excel was like when I was still busy with my MSc data. So I was looking at the banking data. So I had to do chi-square calculations. So initially I started with Excel, and then it was so laborious. I had to do all the observed data with Excel and the expected with Excel. So everything was manual. So, and I had about 5 different parameters I had to do chi-square for. So it was just laborious and so frustrating with the mistakes I had to do. So, and from that I had to learn SPSS quickly, and then I went from Excel to SPSS. I just only used Excel just to learn my data and then loading everything to SPSS, and then I think that's what saved my time. But initially it was so frustrating using Excel to analyze my data.
Oh, absolutely. And I think, yeah, I agree with you, Peter. It's so frustrating. And SPSS is a good alternative for data capturing as well. It is a statistical package. However, I think it can be used, and especially if you set your variable view up so that you can, that's now the back end of your metadata. We can say, okay, 1 is this, 2 is this, 3 is this. So that's great. Yeah, thank you so much for sharing, Peter. Much appreciated.
Yeah, thank you.
Right, I think we should move on with everything that I'm just going to summarize. The next bit I'm sharing my screen is exactly what you have mentioned in the room. Thanks everyone for sharing. Spreadsheet really have different functionalities and purposes for researchers, right? Data entry, which we heard a lot, organizing data, subsetting and sorting data, statistics and plotting. We do a lot of different things with spreadsheets, but things can go wrong, yes? They say spreadsheets are good for data entry, but in reality, we tend to use spreadsheet programs for much more than data entry. And the data set you downloaded, we're going to have a look at it now. And I think if you've looked at the title of the data set, it's called messy. And it's definitely what it is. It's a messy data set. But we use sometimes, I have never used spreadsheets, so I can't really speak from experience. But we create tables for publications, summaries, make figures, etc., etc. But generating tables for publications and spreadsheets is not optimal, because I think those of you who have published know that the journals would like high quality images, and I don't think that's what Excel's strong suit in a sense. So we are going to have a look again about the different, I want to say, functionalities of Excel. And let's see, using data sets for, or spreadsheets, sorry, for data entry and cleaning. So we're going to look at how do we format data tables and spreadsheets? How do we format problems, dates, quality control? And we chatted a lot about what we're going to be doing today. And we are going to jump into formatting data. Righto. So we're going to chat about describing the best practices for data entry and formatting in spreadsheets, and applying best practices to arrange variables and observations in a spreadsheet. I just want to highlight, I'm running through this information with you. This is not what the rest of the workshop is going to be like. It's going to be a lot more live coding. Hopefully when we are done with spreadsheets and open and refine start, you're going to kind of have a good taste of that. R is definitely not going to be like this. So the most common mistake made in treating spreadsheet programs is using it like a lab notebook. How many of you have made comments on the side of tables in Excel? You don't have to answer, I'm just just think about that. How many of you guys have put color on a certain, let's say, a cell? How many of you have made it italic or bold? So we make notes, right, when we kind of capture these things. So using the power of computers, we can manage and analyze data much more effective and faster than Excel. So we are going to quickly have a look here at the note they put in the lesson for us. They said the best, oh, my thing is just, if I highlight it, something else comes up, so apologies. The best layout formats, as well as software and interfaces for data entry and data analysis, might be different. It is important to take this into account and ideally automate the conversion from one to another. James mentioned how they were looking at data and filtering out data in Excel. However, Peter said he moved from Excel to SPSS to capture data. So James had one purpose, but Peter had another purpose as well. So keep that in mind, please, when it comes to data capturing. Keeping track of your analysis. Now, tip number 1. Whenever you use your data set, make a copy. Never use the original data set. And this is where R is so absolutely strong. R, you import your data and then you will make various, they call it data tables, but let's say smaller versions of your data set. Never ever will you edit your original data set. So this is tip number 1. Create a new file with your cleaned or analyzed data. Don't modify the original data set. So that if you have captured your data in Excel, the most important part is that you have a master, a raw copy in a folder. It's read only. No one can ever, write over that. And always file, save as, and then you can do analysis after that, right? Keep track of the steps you took in cleaning your analysis. You should track these steps as you would any step in an experiment. We recommend that you do this as a plain text file stored in the same folder as a data set. So you can see in the screenshot I'm showing you now, and this is why I'm showing you the pages rather than trying to bring it up the whole time. You can see this was done in a Mac, but it shouldn't be much different. You have the data over there on your left-hand side, and then you see the notes, which is in a README file, a text file, a notepad file. Maybe you have a Google spreadsheet or a Word file. I think that is absolutely essential. You need to keep notes of what you did. So in the example here, they say processing notes on survey data, work done, transferred, and the raw data to the clean data, and the neat data. Sorry, there we go. Sorry, yeah. Sorry, Natasha, I just accidentally asked you to unmute. Ignore that, please. So you can see the notes that was made. Step 2, in 2013, Clean created a species column and moved information from header to that column. Step number 3, in 2013, Clean. But you can see they're using tabs, right? And there's a drawback to using tabs. I'll talk about that in a bit. 2013 Clean, put all the different tables together into one table with columns, date, collected, plot, species, sex, and weight. So you can see this is great. You're using Excel sheet, you're making notes, what you did where, to kind of follow and backtrack your steps. But it's still very much a manual process, correct? So you can put these principles in practice today during our exercise that we are going to look at. So another note, they are warning us in, this is out of scope for the lesson, but for information how to maintain version control over your data, look at the lesson in Git. I'm going to copy the link here. For those of you who want to learn more about Git, GitHub is also a tool that we use at the Carpentries. It's free to use as well. You can store data there, you can create websites there, etc. But it's not the purpose of this workshop to teach you about that. So structuring data in spreadsheets. This is now going to be very interesting. The cardinal rule of using spreadsheet programs for data is to keep it tidy. The data set you download earlier is definitely not tidy. I'm just giving you a tip. Put all your variables in a column. You can see date collected in a column, plot in a column, species, sex in a column, weight in a column. Put each observation in its own row. So you can see the first row is observation. The second row is an observation. Third row is an observation. Don't combine multiple pieces of information in one cell. Sometimes it seems like one thing, but if you analyze your data, the program's not going to know what this means. And I want to allude you to the species sex column there. There we're seeing DM, I have no idea what DM means, but it's male. Then we have DM female, DS female, DM. We put two pieces of information into one column. I want you to think to yourself, how difficult will this be to analyze this data? Quite, I think, frustrating as well for you in the end, trying to figure out what went wrong when you run your analysis, maybe in R or in SPSS or Statistica or any other program, right? Leave the raw data raw. I explained that to you sooner. I honestly, once the data is captured, it's been quality controlled, it's been cleaned, I made it read only. It just forces me to, and read only can be done by saving it a certain way. It depends on what program you're going to use, right? But it helps you that even if you work as a big research institute or group on one data set, no one can change that data set. And export the clean data as a text-based format like a CSV, comma-separated values. We talk about this in the end of the lesson as well. So we looked at the little column, well, little table I alluded to earlier. We have data from a survey of small mammals in a desert ecosystem. So different people have gone to the field and entered data into a spreadsheet, and they keep track of these things like species, plot, weight, sex, and date collected. And they were keeping track of the data. It looked like that. But as I mentioned already, the problem here is species and sex in that column has been entered as one variable. This is going to have a lot of issues when you start analyzing those data. So columns for variables and rows for observations, we already spoke about that. The rule of thumb, I would just say this is the golden rule. Columns equals variables, row equals observations, cells equals data. I'm going to put this in the, there we go, I'm going to put it in the chat. Columns are variables, rows are observations, and cells are particular data points, right? This is, I think, not just a rule of thumb. This is absolutely the golden rule. So we are going to move over to the discussion here. And just to tell you a little bit more about the data set we are going to be using. So the data set comes from a portal project teaching data, a portal project teaching program. And the data is used in the ecology lesson, which are observation of small mammals in southern Arizona. So this is part of a project studying the effects of rodents and ants on the plant community that have been running for almost 40 years. So the rodents are sampled on a series of 24 plots with different experimental manipulations controlling which rodents are allowed to access which plots. So the real data set that has been used, this is a real data set, right? We're not using fake or made up, and it's been more than 100 publications, but we have simplified it for this workshop so that people like me coming from behavioral science can teach it. No, I'm just kidding, right? Yeah, I come from an educational psychology background, but quantitative. And the first time I taught this lesson, I had to learn what is a hind foot and all these fancy ecological terms. But I'm well versed in it right now. So we are going to go back to the Etherpad online 101. I will link it in the chat for you. And I think here we can go into breakout rooms just to, spice it up a little bit. I want us to look at exercise 2, and I'll run it through with you before I open the breakout rooms. We are going to take the messy data, and you'll see on line 104, I linked the download link for you there as well. And we're going to describe how would we clean it up. So you can download the data by clicking on the link I provided. You can open the data in your spreadsheet program. Then you can see that there are 2 tabs. 2 field assistants conducted the survey, one in 2013 and one in 2014. And they both kept track of the data in their own way in tabs 2013 and 2014 of the data set, respectively. Now, you're the person in charge of the project, and you want to be able to start analyzing the data. So in breakout rooms, identify what is wrong with the spreadsheet. Also discuss the steps you would need to take to clean up the 2013 and 2014 tabs and to put them all together in one spreadsheet. Important, do not forget our first piece of advice: to create a new file or tab for the clean data. Never modify your original or raw data set. So after we go through this exercise, we'll discuss it as a group, what was wrong with the data and how would we fix it. So what we're going to do, we have, let's say 11 minutes before, let's work on this until the hour, and then we'll take our 10-minute break and we'll come back, and as a group, we'll discuss this, okay? Any questions before I open the breakout rooms? Nope. Okay, let's see how many. We are 17. I'm gonna also add Amy and Anne into the 2 breakout rooms so that we can have helpers in the room as well. So allow me to quickly do that. Apologies, everyone. I'm going to make the breakout rooms quite big on purpose so that we have a good group of people to help each other with that. So let's say you have 20 minutes to work on this exercise, and then we're going to take a 10-minute break. I will communicate and let you know the whole time how much time's left. And then we will come back 10 minutes past 10 in South African time. So 10 minutes past the hour. And then we can continue. Righto. So here I'm opening the breakout room. I'll see you in a bit. Angia, how are you doing?
Hi, Angelique. I'm good. How are you?
I'm good, thank you. They're in breakout rooms at the moment, and then we're going to break for about 10 minutes, just to take a bit of a comfort break, and then we come together. We're gonna carry on with the spreadsheets lesson.
Okay, I'm actually just here to like watch on the first day.
You can go ahead, yeah.
Right.
Cool beans. Okay,
Yay.
I'll see you in a bit. Bye.
Okay, right. See ya.
Right, everyone, it's 10 minutes past the hour, and we have a couple of things still to cover before Refilware takes over. Let's jump into looking at what you did in the breakout rooms. We had 2 groups, so maybe we can ask someone from each group to maybe just give us a highlight of, or anyone. Let's not do that. Let's say anyone who wants to say, what did you see on these messy data sets? What happened there? Who would like to start? Go ahead.
Okay.
I see you unmuted yourself. Hello.
Hello.
Yes, can you hear me?
Yes, I can hear you. So yeah, we've got ourselves group X. So maybe
Great
I can share
stuff.
the screen.
Go ahead. Yes, you may.
All right. I think you can see this.
Let me, yes, I can. Woo, I'm impressed. Look at this note. Go ahead. I'm looking forward to hearing from you.
Yeah, well, just well, there's some observations. Some may be correct, some may be incorrect. But so the first thing was that the tables should be 1. So information from the three tables, either if you look at the sheet for 2023 or 2024, this information can simply be put into one table. And yeah, and then if you look at the table for 2023, so the unit of weight is not required there. So I think let me do this. Let me share the table itself so that you see what I'm actually saying. Yeah, so so we had this table here. Yeah, so if you look at, yeah, I think you can see it here. This is 2023, so I'll read out what we were finding. And so, yeah. Okay, I'm having trouble doing this. Okay, right. Just this. I've got 2 screens here. All right, yeah. So the unit of measure here is not supposed to be there. I think you can see that. Because then the software will not read this correctly. This will be something else. Yeah. And then the formatting of the years are inconsistent. I think that was the other problem we detected. So if you look at that format there, okay, this is a bit consistent, but if you look at 2014, you see these 2 formats, that one for plot 1 and that one for plot 3. Yeah. So the software again will pick this incorrectly. And then if you look at this format also, I'm not sure if the software will be able to decipher. All right, this is okay, but well, I think these are 3 are consistent, but the other one is not.
Yeah, that's a problem.
Yeah, and then if you look at the species formatting here, if you look at plot 4, there's a combination of the species and the sex. So this should be, so this should be separated because these are 2 variables. Yeah, so this is correct. Yeah, but not that. And yeah, so, and then if you look at the column for the title for plot 4, let me just say all the plots. You have plot here. So these are rows as you told us. So this would be like observations.
Supposedly,
but instead,
yes.
So if this should be, it's best that plot is a column, they need to be a variable. Yeah, and then you'll be able to process this data as plots in case you want to see the effects as a variable. Yeah, and then also if you look at the writing of the word weight here and weight there, so these become 2 variables already. If you were to process this into one table, then this, I think you're having 2 ratings there. Same applies with species sex, different variables.
Yeah, so the naming wasn't consistent either.
Yes, yeah. So yeah, I think those are the key observations. And also if you look at that, I think it's similar to this problem here. The soft, so this is text already. I'm not sure the software will pick this as a number. Yeah, so those are numbers wouldn't be good, but this will be picked as something. Yeah,
because you already put the unit in. I think that's metadata. That's kind of a problem as well.
Yeah.
Cool.
So for the solutions, so we suggested by word to say this, we should create one table. These don't have to be separate, for example. And these do not have to be separated. You can create one table, and then that way, instead of saying plot 1, plot 2, plot 3, plot 4, then I'm going to have a column for plot, and then that's going to be a variable. Yeah, so it will avoid also problems such as weight there and then WGT, because then you'll have one table which has got weight throughout. Yeah. And then, and then once that is done, I think the date format, then if the table allows to enter,
We're going to be chatting about how to format dates in a bit, so don't worry about, but it's great that you picked that up already. That's great,
Yeah. So I think that was the key, I think, solution. If these are combined, then you'll have, and then you remove rows like that. And then you'll have consistency in the variables as columns. Yeah. So
thank
we
you so
are
much.
open. Yeah. Thanks.
Cool beans. Right.
Yeah, but maybe my colleagues can add a few things. I don't know. Yeah.
Let's hear. Anyone who would like to add to Group X's observations?
Yeah, we are probably good to go.
Oh, Amy says she's sending her dirty data to you in the future. Sorry, you've got yourself some extra work. In the chat. I'm going to stop your share screening quickly. Thank you so much. Anyone else would like to add anything to this very thorough observation? Thank you so much.
Sure. One.
Go ahead, James.
So would you like, but I just wanted to ask, would you like us to raise hands before we talk?
You can write hand in the chat. But I can see when you unmute yourself. We are a small enough group, but maybe just if there's going to be multiple individuals, we can put hand in the chat, because I see the raise hand features not always for everyone here. So thanks, James, for raising that.
So there's some missing data. So we are going to need to put something in the cells that have missing data rather than leaving them blank. And what I would normally do is put in an NA, except in this case they've coded one of the species names as NA.
Problem.
Which means that either we need to use something else to denote missing data, or we need to change the code for that species.
Yeah, true. We're going to chat about that in a bit. You guys are like really picking up all the errors. I'm very impressed. Well done, group. Well done. Before we move on, we have a minute for another observation. Anyone else would like to chime in? Right, okay. I'm going to start sharing my screen now. Thank you so much. If I can, there we go. Let's go back to the lesson. And we're going to look, and you already highlighted most of them. So this is going to be, let's say, revision. So I'm going to go kind of a little bit quicker through the problems, but more the solutions, I'm going to focus on them. So common spreadsheet errors. We're going to look at, I know we already, Group X mentioned, using multiple tables on one spreadsheet is problematic. How is your statistical analysis program going to pick up what is data? This should have been merged into one data set, one usable form. There's multiple other issues in that multiple tables that we saw, but let's just unpack it systematically, right? They also mention here, same field name. So we had weight, WGT, we had some places where they had grams, right? So that's problematic. So let's move on to using multiple tabs. Whoosh. It's not a good idea for two reasons. Let's have a look what the text says. It says, you are more likely to accidentally add inconsistencies into your data each time you take a measurement when you start recording data in a new tab. It's not even rule of thumb. The golden rule is one data set, one variable, one observation per line, one data entry. That variable that said species and sex, that's also a big no-no, right? Even if you manage to prevent all inconsistencies from creeping in, you will add an extra step for yourself before your analysis. My motto in life is work smart, not hard. And this is definitely, I don't want to do 40 minutes of work that could have been 20 minutes of work. So this is what they're alluding to here. So using multiple tabs, definitely not something that I would recommend. Here is some documentation. I want to quickly, on how to, I just want to save that. There we go, right? How to freeze a column. So they're talking in here about using your data sheet. It might get really long. Let's say you use big data and you have thousands of entries, right? And you can't see your column name anymore. But you can circumvent this in a sense by freezing your column headers in Excel. And I shared a link for you in the chat, and it's in the lesson material as well, of how you can circumvent that. Now, James, you spoke about missing data, not filling in zeros. This is, and we're going to talk about null values in a bit, right? It might be that when you are measuring something, it is usually a zero. I can't think of an instance in psychology why this will be, but you just leave it in empty, right? We should, I don't know why my camera keeps going on. I apologize, everyone. When something is zero, put a zero down, not just a blank, because as James has alluded to, that a blank could be missing data, but if a zero needed to be entered for some reason, however you code in your data, then it's not a true zero, is it? Or true missing data. You're not really sure what it is. So a blank cell can be misinterpreted for missing data. So don't take a shortcut, I wanted to say about that. So using problematic null values. So this is something I ran into in my PhD. So I used -999 for missing values because that was the convention back then, right? The problem with this is if I do not tell the statistical program, this is how I'm coding my missing data, it's going to see -999 or 999 or 0 as an actual value. And just imagine what your data is going to be skewed in one direction, skewed in another direction. So think carefully about how you want to code your missing data before you start doing that. So they say a solution will depend on a final application of your data and how you intend to analyze it. But it's essential to use a clear, defined, and consistent null indicator Blank cells are the best choice for most applications. But again, if you look at above, maybe a blank cell's a 0. So this is kind of where things get all messy, right? Blank cells are the best choice. When working with R, NA might be an acceptable null value choice, but James mentioned NA could be a way that we code things. There are many reasons why null values get represented differently in data sets, and sometimes confusing null values are automatically recorded from measuring device. But that's fine. We can have open refine, and Refillware is going to help us use that in a bit. Hello, Refillware. But let's look at the different problems and recommendations this lesson gives about null values or different ways of coding your missing data. So if you use null, it's indistinguishable from a true value, and they recommend to never use that. Blank, it's very hard to distinguish that is this a missing value? Is it a human error? So it works with R and Python. And they recommend that this is the best option, but I would still think we are going to do an R. They're going to show us how to tell R these blanks are missing values. So don't worry about that. I'll show that to you in the days coming. Minus 999 and 999, we should avoid that because many other programs doesn't know how to recognize this. We spoke about NA, capitalized or lowercase, but it could also be an abbreviation for like North America. So it's a good option, and R reads it as a missing value. So that's okay. R, a \A, it's an alternative form of NA, but it's often not compatible with software. So we should avoid this. If we write the words null, can cause a problem with data type. So avoid that, because remember, when we do statistical analysis in here, now we start putting letters into the data. So usually your data are 1s, 2s, 3s, 55s, and now we have null. This might become really problematic. No data. This can become a problem, and it contains a space. So I would rather avoid this. You can write missing, the same issue as writing null. I would avoid that. I'm not exactly sure why minus and plus is in here. I would just totally avoid that, right? Using formatting to convey information. Now, group X highlighted, it's similar type of issue. So here on, you can see where I don't know if you can see my mouse, apologies. 157 is in yellow, 218 is in yellow, and then there's a little little legend here at the bottom. If we would import this into any statistical program, they won't mind, the color is not going to mean anything, but that measurement device not calibrated, that's going to give you a lot of errors. Just importing the data is going to be a big problem. So the solution would be to create a new field to encode which data should be excluded. So has it been calibrated or not? Because this is what the researcher was trying to convey in the table above, right? So you can see the data set has been nice and tidied, and it's now including a new column that says calibrated. But what we are seeing here as well, there are a lot of blanks, meaning they probably mean that is a missing value. They don't know if the first entry was calibrated or not, but there's no measurement in any way, right? So that's something we're going to have to look at when we use R. Using formatting to make the data set look pretty. Merging cells. I would not do that. Merging cells to make it look pretty. And I probably used that when I did the timetable when I was 16. I told you it looked pretty and the colors look pretty, but nothing would be able to import into R later on. So placing comments or units in a cell, we looked at that during group X's screen share. We saw that weight column had the gram in. Your software analysis package is not going to be able to read this. So I would remove that from the get-go. Entering more than one piece of information in a cell, we saw with the species and sex. The statistical program is not going to know what is species and what is sex. and what does this mean in statistical terms? So problematic field names. So the way you name your columns, and we looked at it already. We had weight, we had WGT, we had weight underscore grams, weight grams. There is a better way of naming. There's a better naming convention. Let's look at the special characters we can use in naming conventions of your variables or the columns in Excel. So let's look at a good name is max temp in Celsius. So this gives you, it says the maximum temperature, and the temperature was not in Fahrenheit, it is in Celsius. That's a good way. So a good alternative would just be max temp, but you're kind of missing a little bit if you really want to include the measurement in this. Well, what the, let's say, kind of the unit of measurement is, then I think the max temp C would be better. And I would avoid anything like getting too much information, special little characters in there that will just confuse the statistical program as well. Precipitation in millimeters, that exactly tells us what that is. An alternative could be precipitation and free CMM. Yeah, some of us, it's not, it doesn't really give you the information. We read now precipitation in millimeters, right? But pre-C, if I showed that to you off the bat, you would not know what that variable was all about. Mean year growth, you see the underscores, that sounds good. Mean year growth, and you see how they're using the capitalization, very much like Twitter, right? And hashtags, to differentiate between the variable name, and that /, it's not going to fly. 6, that sounds good. Male, female, yeah, that's not making any sense, right? Weight, or W full stop. Yeah, I don't know. Cell type, yeah, they're making use of that capitalization of the words. You can, we touched on the cell type, but my go-to is that I would use underscores, and I would use abbreviations of a word, right? No spaces. That's kind of my go-to when I do this. Observation 1, first observation, or first obs. I don't know, that sounds like a bit of a slang. Oh, it's my first obs, people. So no, let's not use that. You can see there's a space. Also, when you import the data into R or any other statistical package, it's going to read it as 2 different variables. It's not going to pick it up as 1 variable. So yeah, let's go down. Inclusion of metadata in a table. That's quite interesting. So you add a legend at the top or bottom of your data table explaining column meaning, units, exceptions, etc. So let's quickly I want to stick just 1 minute to metadata, because let's look at, or let's think about the messy data set. A lot of the little messaging and color coding was there to give metadata to the research. Metadata meaning data that will help them interpret what this data is all about. So there might be better ways to do that. SPSS, I think, Peter, is it you that spoke about SPSS? SPSS is a variable view where you can put metadata at the back. So that's what differentiates SPSS from Excel. So you're kind of saying that particular cell is measured by 1, 2, 3, 4, 5 means certain things. Maybe male was coded 1, female was coded 2. So that's a metadata you put in the back. But they say here, recording data about your metadata is essential. You may be on intimate terms with your data set while you're collecting and analyzing it. Sorry, but the chances that you will still remember what that variable means, I think this is a bad naming of a variable, by the way, means single member of group, for example, or the exact algorithm you use to transform a variable or create a derived one after a few months or a year. Now, earlier today, I spoke about when we clean our data and we make it nice, we have a little notepad next to us and we make these comments. That might be an option as well. There are many reasons why you might want to examine or use your data. So, and to understand your findings and to verify findings, you need to know what you're doing. Right. So your data should also be machine readable. And we looked at that when we alluded a little bit to that with the naming of variables. When you said cell space type, that's not a good convention. It should be maybe cell type, one word, or cell underscore type. That would be better. And I want to share this with you in the chat on. So Angelique, you're telling us it's very important, but what now? This link will, it's not the purpose of today's lesson to show you how to code metadata, but more to highlight for you why it's really important to keep that information somewhere. So I shared a link on an online course, how to use metadata. So there we go. Hopefully we can help you just gain access to more information on how to make the back end, meaning the metadata, a little bit more accessible and user-friendly for you. So I want us to quickly just run through what we discussed now, because we went through it really quickly. Avoid using multiple tables on one spreadsheet. Avoid spreading data across multiple tabs. Record 0 as zeros. Use an appropriate null value to record missing data. Don't use formatting to convey information or to make your spreadsheet look pretty. Place comments in a separate column. Record units in column headers like temp _C for Celsius. Record, include only one piece of information in a cell. Avoid spaces, numbers, and special characters in column headers. Avoid special characters in your data, and record metadata in a separate plain text file. So we spoke about the problems regarding dates and how the dates in the messy data set, the formatting was not right. So we can quickly have a look at what that is all about. So dates in spreadsheets can be a problem. For one thing, dates are stored in a single column. At the ones we saw, it said the 1st of the 9th of 2030. It's one column. But in reality, we don't use necessarily the date or the month. Maybe the month, right? But the year particularly. So what we're going to look here at today is how do we split date from month from year? And that's the next exercise we are going to go into right now. So I'm going to quickly screen share the Etherpad. And we will do this on our own. So the challenge is pulling month, day, and year out from dates. So let's create a tab called Dates in our data spreadsheet and copying the plot 3 table from the 2014 tab that contains the problematic dates. I want you to extract month, day, and year from the dates and the date collected column into new columns. This can be done by using the functions in Excel, year with the curly brackets, curly brackets, month curly brackets, and day curly brackets. Just a tip, you're going to have to use a X. There we go. That sounds a bit better. Make sure the new columns are formatted as a number and not as a date. You can see that even though we expected, this year 21st, the year is actually 2015. So that's a tip. What happened here is that the field assistant who collected the data for year 2014 initially forgot to include the data for plot 3 in this data set. They came back in 2015 and added the missing data to the data set and entered the dates for plot 3 without the year. Excel automatically interpreted this year as 2015. The year the data was entered into the spreadsheet and not the year the data was collected. Thereby, the spreadsheet program introduced an error in the dataset without the field assistant realizing. So let's take 5 minutes and I would like you to do exercise 3 and we'll come back and have a look at what the final answer is. Right, everyone? Right, everyone. I was thinking I brought up the spreadsheet so I can show you how I would have interpreted this exercise. I hope you all can see my sheet. So it's a little bit bigger than, I don't know why, let's just make it smaller. There we go. Right, so this is the plot 3 data. We wanted to add a day, this is very ugly, month and year columns, right? So if we want to extract that, what did we say again? Let me go to the cheat a bit. Year, month, day, great stuff. So we're going to do this, day, we're going to highlight that, boom. So this is quite something we saw, there's a comma. So we need to edit a couple of things, but now I'm going to just cheat. What I do, I just kind of double clicked with when it made a little X and it kind of did all that. So it's giving me a decimal, and we know that days don't have decimals. So I right click and I say format cells. I'm going to say I want 0 decimal, and there we go. That's gone. So let's do that for month. And I'm choosing the same cell, and that's the first month, and I'm going to go boom, some bit of magic. But this is 2015 they talk about now. Something here is not going to be so good. Let's see, because we can't see. This is actually 2014. So let's see what's going on here. Oh, oopsie-daisy. Right. So when the research assistant captured the data, they just put the 1st of the 8th, 2nd of, 8th of January, 18th, etc., etc. But because it was that particular year, picked it up. So we need to go and fix this. So you can see it picked up there 2014. So I'm just going to do one. I would just fix it here and just say 2014. Boom. And it changes that, but still it looks like that. So we need to format the cell. So I'm going to right click again and say format cells, and I'm going to date. And here they give us all the various formats we want. But the one I would highly suggest is the day, the day, the month. No, that is America. Let's quickly see what's this. Okay, there we go. The day, the month, the year. So we're going to enter that. Boom, boom, boom. And let's see. Yeah, that's not going to work because I did not edit the rest. So this is going to be a manual job. Sorry, apologies, everyone. Why did I? There we go. Right. So here, if we change, we highlight everything, you're going to see the formatting is going to change. There we go. We want that one, right? Okay, but it still says 2015, and that's going to be a manual entry we're going to do. So that is how I would have solved this problem. Let me quickly close the spreadsheet and we can continue with the next bit. I'm going to skip the next exercise in the essence of time, but there's a preferred date format. I have my own one, and that's the one I shared with you now. It's much safer to store dates in a year, month, day format and separate columns, or as a year, date of year in separate columns. It depends, I think, wherever you are around the globe. South Africa likes the date, month, year, or year, month, date format, and not necessarily the year, date, month format as they traditionally use in the US. So that's my suggestion. So date format in spreadsheets, you can see there's a bunch, and we just spoke about that, but very important, dates are stored as integers, numbers, right? So the first thing you need to know in Excel is that Excel stores dates as numbers. See the last column in the above figure, you can see the number there. So on row 2, the 2nd of July is 41822. And it's very important that Excel actually starts its date from all time from the 31st of December, 1899. That's it. I don't know why they decided that. And that's why July the 2nd, 2014 is 41822. So that's 41,822 days after that. It does, I don't know. Yes. I don't know why Excel decided that, but that's what it is. But yes. So if you say B2 plus 37, meaning B2, which is 2 July, plus 37, it will pop out as 8 August. That's an interesting fact that you're not going to use in research. I'm not going to allude to more about this, but to understand why sometimes when dates aren't in the right formatting and it gives you numbers, this is the reason why. So I am going to, I want us to do this exercise because that's going to be very interesting. What happens to the dates in the dates tab of our workbook if we save the sheet in CSV format and then open the file in a plain text editor like a notepad? Let's try that. So we're not going to do exercise 4. This is extracting seconds and stuff. I don't think that's necessarily very relevant to the group today, but let's do exercise 4 quickly. I want you to take 5 minutes, do that, and let's see what happens. Right, everyone. While you are hashing through that, I think I'm going to go through the solution because it's almost time for our break. And I do want to stick to our break times. So the first step would be to click to the dates tab on the workbook and double click on any of the values in the date column. Notice that the dates display 2015. We know this because we had a look at that. Then you're going to go and say select file, save as, in Excel, and then the drop-down menu for format. Then we choose CSV UTF-8, which is comma delimited, and you save that. You'll see a pop-up that says this workbook cannot be saved in the selected file format because it contains multiple sheets, which is a problem we have identified often today, correct? Then you can navigate to the file in your Finder application. This is written in a Mac, so you just go to Explorer in Windows and you see where the files. You right click and you say open with, and then you choose Notepad or any other text editor you have. Maybe use Atom, I don't know. And then you can view the file. You notice the dates display as month, day without any year information. Now if you right click on the file again and you open an Excel, notice that the dates display with the current year, not 20. As you can see, exporting data from Excel and then importing it back to Excel changes the date once a year again. So technically it should have been 2014, but it displays as 2015 when you are in Notepad. And when you come back and you save it there and you open it again, in Excel, now it's 2024. This is why we need to save things correctly the first time. Right, everyone, let's take 8 minutes break. We'll convene on the hour again, and I will see you then. everyone. It's on the hour where I am. I would like to wrap up the last bit so we can start with Open Refine and Refill. So we are going to look at quality assurance, and this is going to blow your mind, I know. And then we'll end off with exporting your data. So quality assurance is we spoke about human error. Sorry, I'm going to backtrack. We spoke about human error and how when we enter data into Excel and we make typing errors, etc. And quality assurance is going to help you a lot to make sure that you don't put in values that don't fall in a particular spectrum. I'm going to show you in a bit, showcase that for you in a bit. So let's think about when you enter data and you can only have options 1, 2, 3, 4, 5, but because 6 is next to 5, you can make a typing error. So if you set Excel up to only accept values 1, 2, 3, 4, or 5, and when you enter 6 when data capturing, it will give you an error. And this is exactly what I'm going to show you right now. So just to highlight, quality assurance stops bad data from ever being entered by checking to see if values are valid during the entry. So for example, if research is being conducted on sites A, B, and C, and the value V, which is right next to B on the keyboard, right, is entered, then you will get a prompt to say, hello, this should not have been there. So to control this kind of data to be entered and the quality assurance we set up, we use something called data validation in Excel or validity in LibreOffice to set the values that can be entered into each column. So first you go ahead and you select the cells or the column that you want to validate. Then on the data tab, you will see validation. It might be hidden a little way, depending how big your screen is, but you see the right mark and the little stop sign almost, right? That is where you will find it. I want to see if I can quickly share my screen with you to show what that looks like on my Excel sheet. So just give me 2 seconds just to open that. There we go. Are you seeing my Excel sheet at the moment? If someone can just give me a thumbs up. Okay, super duper. Thank you so much, everyone. So when we go to data, do you see under data tools, this is what mine looks like, right? Data tools. And if you highlight the data validation, pick from the list of rules to limit the type of data that can be entered in the cell. For example, you can provide a list of values like 1, 2, and 3, or only allow numbers greater than 1,000 to validate entries, right? So let's quickly say, I'm going to just clean up a little bit here. So give me a second. Let's see, I'm going to highlight all those and let's see if I can quickly demonstrate for you how this works. So allow any value, a whole number, a decimal, a list, a date, time. So you can have a list in there as well. You can say, I want a whole number, data between the minimum. What would the minimum be there? Let's say 1 and 190. That's what they show there. And then I can have an input message. You can say when cell is selected, show this input message, say limits. That's just things I'm making up here. Enter values between 1 and 190. So when you put that value in there, I'm gonna showcase this to you rather. It's rather just an error alert. So stop and say error. I'm making these things up now, right? As we go. This value is not between, Angelique, 1 and 190. And let's say, okay, and see what happens. See, limit, enter values between 1 and 190. So I'm going to put 200. This value is not between 1 and 190. So that was a very quick showcasing of you technically should do this before you enter the data, so I cheated a little bit. But this quality assurance tool absolutely amazing. So maybe I went really quickly through this. So I'm going to show you what I did again. Right? So I highlighted the data. I went to the data validation tool, and here's settings. You can say ignore blanks as well if you want to apply these changes to all the other cells. You can have an input message, you can have an error message, and then here we go. And there's many other options. Let's just take a look at the number options again. So I chose a whole number, but there's decimals, there's a list. So if we go on list, this is going to be quite interesting. List is going to say source, but I'm going to show you now an example on the website what source means. So let's say you want to say a particular name. So let's say there's 3 animal species. You only want one of those 3 animal species to go there. So you can eliminate spelling errors, number 1, by choosing that. You can put like drop down arrows in, all these type of things. So let me quickly close here so I can showcase what they showed here. So repeating again what I did, data validation. You can choose whatever value you want here. They decided in this example to say whole numbers between 1 and 24, and you ignore blanks. They say the value you have entered not valid, the user has restricted values, that's the error. You have an input message. As we showed there, we have an error message. But now with the list, this is where the list comes in. You see in the spreadsheet, they already have those 3, and I'm not even going to try and pronounce them because I'm going to butcher them. I'm not even going to try now. And you can see in the source, you could highlight those 3 names, and then you can add them into your list in there. So quality control, another trick. So I used to do a bit of market research, and sometimes when I want to do a quick and dirty check on when data doesn't look right, I would sort the data from small to big to small, or A to Z, and then at the top ends and the bottom ends of the data, you're going to see things that don't look right. Like the -999, if you use that and you sort it, then technically all that must then be at the bottom. So you can kind of see what is HaHa data and non-HaHa. So that is quality control in a quick nutshell, but I want to end with exporting data. So storing the data you're going to work with for your analysis in Excel, the default format is XLS or XLSX, depending if you've set it up differently, etc. So, and this is now if you follow the absolute default settings of Excel, but it's not a good idea. And why is it not a good idea? Because it is a proprietary format, and it is possible that the in future technology won't exist to make, it might not use this technology. I think that's what they're trying to say here. So it might be possible that you can't open your file. Other spreadsheet software may not be able to access open files saved in a proprietary Excel format. Different versions of Excel handle data very differently. How many times have you opened an Excel sheet and they say, oh, this is of a previous format. Can I open it this format? Can I open it in that format? This is probably the reason why. More journals and grant agencies are requiring you to deposit your data in a data repository like Figshare. You downloaded the messy data from that repository. So GitHub is another repository you can upload your data in, but Figshare is specifically there to upload data and keep it safe, especially when you use sensitive data like names, contact information. And we have the POPI Act in South Africa, which makes it very difficult for people to access data without the right permissions. So Excel formatting will not be accepted by journals or grant agencies if it's not in a repository, right? So it needs to be in the formats that we're going to chat about below. And the above points also apply to other formats, such as open data formats used by LibreOffice or OpenOffice. So let's have a look quickly here. So when you save your data, and again, this is done in a Mac, so it's not going to look exactly the same. You can go to File, File, Save As. In the Format field from the list, select comma separated values. double check the name and the location where you want to save, and then hit save. Look at the naming convention of the file as well. Survey underscore data underscore tabs, right? Comma separated value. A note on cross-platform operability. By default, most coding and statistical environments expect Unix style line endings. Don't worry about the fancy word there. There as representing line breaks. However, Windows uses an alternate line ending signifying all those characters by default. Again, don't worry too much about the naming convention on that. If you open your CSV file on a different system that does not pass the character, it will interpret it differently. So have a look here. So in Excel, it will show column A is data 1, column B is data 2. Then entry 2 is 1, entry 3 is 4. But if you open it up in another, how can I say, format, it might show data 1, data 2, 1, because it's not made for columns, etc. Whoever opened this in this other format, that program was probably not made for another format. You'll see a weird character being added, that R's. So there are a handful of solutions for enforcing uniform Unix style line ending. So when exporting from Excel, save to a Windows comma separated value. So that's an alternative as well, a Windows comma separated. If you store your data file under version control using Git or GitHub, you can edit the .gig/config file in your repository. And I'm not going to bore you with this. So one day when you start working with GitHub and you want to add there, you can email me, angelique@carpentry.org, and I'll help you set it up. And what I'm going to do is the rest is basically setting up Excel and R, but we are going to use packages in R that makes it a little easier to import data. So caveats on commas. In some data, so they said comma separated values, right? CSV. So the data to tell, let me just backtrack, to tell R or any other statistical program that data, that's one particular entry, they use commas. So it's 1, 2, 3, NS, CA, NS, CA. So that comma tells them it's another column. So, but there are caveats to this, and this is what we can chat about now. In some data sets, the data values themselves may include commas. Now, this even further complicates it. So let's say you want to take the length of a field, or how far someone can run, right, in 5 seconds. That distance will obviously differ. So when we use commas, saving something as comma separated value might be problematic. Also, it is true in countries that use commas as decimal separators. How many of you, if you do like a budget for your project in Excel, have found if you use a comma and you try to sum everything, it doesn't work, you have to use a full stop, right? So this is kind of the thing we are talking about here too. In this case, the software which you use will most likely incorrectly display data in the column. As I mentioned, this is because the commas which are part of the data values will be interpreted as delimiters. And this is why you should look at TSV files. And that's also another option. You can send things out. So let's just do a key point summary here. Data stored in common spreadsheet formats will often not read correctly in data analysis software, including errors, introducing errors into your data. Exporting data from spreadsheets to formats like CSV or TSV puts it in a format that can be used consistently by programs. So let's just differentiate between CSV and TSV. So CSV is comma separated values, and the other one's tab separated values. So if you know your data has commas in, meaning that it's a length or it's a monetary type of thing or something like that, then TSV would your go-to thing. So then R will know you have actually use commas as part of your data. If you don't, in psychology, we don't use commas, and we code things as very categorical data, right? So 1 is true, 2 is false, that type of thing. yes and no, 1 and 2, male and female, 1 and 2, or 0 and 1, or however you code the data. Then we'll use CSV files. And ladies and gentlemen, this is Angelique ending of the spreadsheet lesson. And I want to just stop sharing my screen, say, give you the opportunity, maybe 5 or so minutes to ask any questions, because I feel like I might have gone through it a little bit too quick in the end, but I do want to give you the opportunity to practice this at home. So the link in the Etherpad, linking to this information, this actual part of the lesson, I will share it for you quickly in the chat, has all the solutions. It has other exercises we did not get through today. You can go and do that at home, but I do think we covered all the work that you need to know going ahead into OpenRefine and R, and how to not have a messy data set. So is there any questions you have for me before I'm going to hand it over to Refilwe? Right, I don't see anything in the chat, and I'm not seeing anyone unmuting themselves. Just a reminder, I'll be here most days. If you have any questions, please DM me. If you have any questions, maybe midnight tonight, you think of something that happens in your data and you wanted to ask me, please feel free to email me at angelique@carpentries.org. Carpentries.org. I'm typing it for you here. I will not be responding midnight, but no, I'm just kidding. But no, I won't be responding at midnight. If you have any questions or would like to discuss something further, pop me an email and we can chat about it. So I am going to hand you over to Refilwe now. Over to you, Refilwe.
Thank you very much, Angelique. That was a great introduction to spreadsheets. Morning, everyone. My name is Refilwe Kakani, and I will be the second instructor for this workshop. So I was thinking, before we get into the introduction, maybe let's just get the what can I say, the data download out of the way. I just wanted to check, does everyone have the data for this next section? The link is in the Etherpad, so I just wanted to check if you have the data. Do you know what data I'm talking about? Do you have the data? Do you need the link? Please let me know.
Perhaps we can share the link in the chat again. Refilwe, what do you think?
Yes. I'm going to do that now. Thumbs up if you have the data. No thumbs. Okay. Okay, let me just get the link for you so we can get the data. Angelique, do you have the link there quickly? I
don't have it with me right now. Give me 1 second and then I'll quickly get it for you.
I thought I put it in the Etherpad. Nope, I did not.
No, there's only the messy data one I can find there. Don't worry about it. I will get it for you. Data,
Thank
boom,
you.
copy link. It is in the chat. There we go.
Awesome. Yes, rodents. Can everybody please download the rodents data, and then when you're done, give me a thumbs up, and then we can get going with OpenRefine. So I'll give you about until 11:25 to download the data, and then we'll start with the session. Are you guys winning? Can I please have a thumbs up? Hey, Angelique, please confirm. Can you see my screen?
Perfectly.
Awesome. And guys, thumbs up with loading the data. If you're having any trouble, please just put it in the chat and then we can help you, and the helpers can also assist you with that. Thumbs up, unmute yourself, say yes, anything.
I'm not seeing any thumbs up yet.
Are you guys still here?
Okay, there's 3 thumbs up.
Okay. All right.
If you need more time to download the data, please let us know so that we can support you in that. But I think people, oh, there's another thumbs up in the chat too. So I think we're good to go if we don't hear from anyone, Rithawin.
Okay, awesome stuff. All right. So this next chapter of the lesson is working with Open Refine. So we use Open Refine to actually help us clean data. We just saw Angelique showing us data that are actually messy and how that can get very complicated when you're trying to analyze your data. So Open Refine is used to save you time in cleaning your data, right? So the data cleaning steps in Open Refine are often repeated. I mean, the data cleaning steps that you use, you often repeat it in multiple files. So the nice thing with Open Refine is that you are actually able to do a repetitive task by replaying the previous action on multiple data sets, right? So when we now go to like publishing or sharing your research with other researchers, you'll find that they require that you show them exactly what you did with your data so that it can be reproducible. Then the great thing about Open Refine is that you can capture all your actions, all the actions that you apply to your raw data, and you can share that with your fellow colleagues, with a journal, or with an institution that you're probably collaborating with, right? So another thing is that in Open Refine, any operation that you do, you are able to reverse. It can be undone, right? You'll see all this when we get into it, okay? So as I said, Open Refine helps us with that. I see a message in the chat. Oh. Yes,
It's
Angelique.
commentary from the peanut gallery, sorry.
it's actually great. I love OpenRefine. So the background OpenRefine, or the nitty-gritties. OpenRefine is a Java project that runs on your machine and not in the cloud. So it is on your desktop, but it uses a web browser as a graphical interface, right? However, just because it's on the web browser does not mean that it needs an internet connection. Once it's on your computer, it's open, you do not need an internet connection to work on OpenRefine, right? Another great thing with OpenRefine is that it does not modify your original dataset. So what it does is you load your original dataset, it makes changes, and what you have to do is then save that new dataset onto your desktop, because OpenRefine does not overwrite your original dataset. And that's great, because sometimes you make a mistake, you don't remember where you made a mistake, and you need to go back to your original dataset, right? So because OpenRefine does not overwrite it, you are able to still go back to your original dataset. I'm sure there's a few of you like me who have had one spreadsheet that has several names, cleaned until maybe you'll call it point 1, point 2, or column 2 clean, column 3 cleaned, or something like that. So the nice thing about OpenRefine is you still have your original dataset, and you can always go back to what you had done before, right? So it doesn't overwrite, right? So OpenRefine it also helps us to get an overview of our dataset. It helps us resolve the inconsistencies in the dataset, something that you had seen or gone through with Angelique in the previous chapter of the lesson. You can also split your data into more granular parts. You can match local data, and as I say, it does not overwrite on your original dataset, right? So what we did before we started, we downloaded the data, but I forgot to ask if everybody has OpenRefine. Thumbs up, please, if you have OpenRefine downloaded. And we can start. Otherwise, please just let us know. We will assist you. I'll give you a minute, 2 thumbs up.
I saw 4 thumbs up in the chat a while ago.
Okay, everybody has OpenRefine. If you do not have OpenRefine, please let us know, because I would hate to lose you in these steps. Everybody good? Okay, nothing yet. All right. Okay, I'm going to continue. If I lose you at some point, please do let me know. So today we are just going to work on importing data to OpenRefine, and then exploring data with OpenRefine. And then tomorrow we will go from transforming data to exporting and saving data from OpenRefine. Okay, so if everybody has OpenRefine, can you please launch your OpenRefine? So I'm just going to close this first, because I had clearly launched it before. So when you launch it, this is the screen that you get. You get a terminal. And then from the terminal, you will get a browser opening. I lost my browser.
Yeah, there we are. I can see it now.
Okay. There we go. Is everybody on the same page as I am? Waiting for OpenRefine to open? Please indicate with a thumbs up, unmute yourself, say, hey, yes, I'm there. Or, yeah, any of the reactions, something.
I am a bit behind, but I'll catch up.
How behind are you? I feel like the others are shy to say, and then we're going to lose most of the class.
No, I was trying to run the exe, and it wasn't really running automatically, so I was going to run it from the folders. But let me just try and download it again and then get it up and running.
Okay, so if the exe doesn't work for some reason, you can use the .bat. Let me just check for you quickly. There. So if that one doesn't work, so I've got folders and folders, you can use refine.bat.
Okay, I'll check it out. Thank you.
Cool. Everybody else on point? Are we good? Or do you guys also need some help to re-download it again or run the execution or the .bat file again? Please let me know, thumbs up, or unmute yourself. Okay, I guess everybody else is okay. All right, so we move. If I'm going too fast, please do let me know. I am here for you and not for myself. Okay, so this next part is we are going to import data. So I asked you to please download the data. The link is in the chat before we started. So what we are actually trying to achieve now is we're going to create a new OpenRefine project from a CSV file. The CSV file that you downloaded before we started. Angelique just put the link in the chat again. Thanks, Angelique. So before we get started, just wanted to let you know, there are several options for getting your data into OpenRefine, right? You can import files in a variety of formats, and this is a CSV and a TSV. Angelique explained that earlier. You can have a text file, a fixed width column file, JSON, XML. You can have ODS files, which are open document spreadsheets. You can have Excel sheets. Sorry, you can have RDF data or wiki text, right? From all these files that I've mentioned, are there any other types of files that you guys work with that you maybe are not sure if you can open in OpenRefine? Please just type in the chat. I mean, I know personally I use a lot netcdf files, and unfortunately, OpenRefine does not open netcdf files. Any other files that you guys use? Mine is netcdf. Anybody else? Okay, I'll assume that everybody uses all these files that I mentioned here. So today we're going to be working on a CSV file. So the first thing that we're going to do, Angelique uses text files mostly. We've got CSV, Excel, XML. Yeah, you work with a lot of files. So this is going to be fun for you. It's going to save you a lot of time with your data cleaning. So what we're going to do is we are going to create a project, right? So on the left-hand side of your OpenRefine screen dashboard, you can see you have create project, open project, import, and language settings. So my create project is already highlighted there. And what we're going to do, we are going to choose a file. We're going to choose a file from our computer. Please don't judge my desktop. So I have my data file under data Carpentry Ecology with R. And here is my .csv file, right? So click on that, open. There we go. So my file's already here. Is everybody following? Are we all on the same screen? Thumbs up, unmute yourself, send a party hat, anything. Okay, so after you choose your file, you click on next, right? So what is it doing now? It is uploading your file onto Open Refine. All right. Just to check, the person who had mentioned that they were still downloading Open Refine, are you okay now? Don't want to leave you too far behind.
No, I'm good. Sorted. Thank you.
Awesome. Thank you. So is everybody on the same page, on the same step? So after we do that, we are going to click on Create Project. You can see your file name here. You put a project name. Automatically, the name of that file just, yeah, was there. So we create the project. You can change your project name if you want. I will not be changing mine. So you create project. Right, so our project has been created. And then what Open Refine is now giving us is what we call a preview of your data, right? So from this preview, you can check for obvious errors. For example, your file is actually tab delimited rather than comma delimited. And so if that's the case, then your preview will obviously not look like the preview that we are seeing here. And then the way to correct that is by choosing the correct separator and then clicking on the update preview button, right? If you selected the wrong file. And then you can start again if you need to upload a new file, right? Is everybody still following? Okay, I think, okay, never mind. We are there. So oh guys, sorry, I lost the update preview. I lost the update preview. But at the bottom, before you click your next, after creating your, or let's just start again. I'm gonna close mine and start again and show you properly. Right. So there. So if you were lost from the beginning, you can follow again. I made a little boo-boo there. So I got rid of the update preview before I actually showed you what is there, right? So we're gonna create file, create project, gonna choose your file. There's my file. Right. So this is you can see the preview here. This is what I meant by updating preview. So if your file was actually not a CSV and it was a TSV or something else, you can change that here. Columns are separated by comma, tabs, or if there's a custom separator that you use, you can change that. If, for instance, maybe before your first row, you have data, metadata that you don't want to include, you can ignore the first few lines. And then you can pass the next one line into column headers. And there are a lot of other things that you can do here. You can play with your data set before you actually start, right? So ours is correct. We have a CSV and we are passing the first one line as column headers. And we are going to leave the blank rows and store blank cells as nulls, right? So I'm just going to create another project, right? There we go. So after we create that, right. After we create the project, we have the preview of our data set. We are going to now move on to exploring data with OpenRefine. I just wanted to check that everybody is still on board. You don't have a problem with your OpenRefine. If you have a problem with your OpenRefine, please let us know so we can send you other ways to actually access OpenRefine and actually work with your data. If you haven't downloaded the data, please let us know. We will wait for you. I don't see anything in the chat, Angelique. You seeing anything?
Nothing.
Nothing in the chat? Okay. Right. So the objectives for this section is to learn about different types of facets and how they can be used to summarize the data of different data types. Right. So the questions that we're asking for this lesson is, how can we summarize our data? How can we find errors in our data? How can we edit to fix errors? And how can we convert column data from our data type to another? I'm just going to put the Etherpad page here just so that we can look at it when we're looking at exercises. Right. So when you're exploring data in OpenRefine, you can do that using facets. So facets are one of the most useful features of OpenRefine. Data faceting is a process of exploring data by applying multiple filters to investigate its composition. This also allows you to identify a subset of data that you wish to change in bulk. So you don't have to do that one by one, right? So what the facet does is that it groups all the like values that appear in a column and allows you to filter the data by those values. And it allows you to edit values across many records of the same time. As we said earlier, you then don't have to repeat this each and every time, right? So one of the facets that we have is called a text facet. Right. So you can go to, if you go to scientific name, which is text, so that's the example that we are going to use. I'm going to click there, go to facet. And as you can see, it is so we're going to choose text facet, right? So after choosing the text facet, in the left panel, you'll now see a box that contains all the unique values in the scientific name, right? You can see there are some things that are kind of different here, right? And then they will come with a number representing how many times that value occurs in the column. You can see that this one appears once, this appears 199 times. So now, what we're going to do is we're going to try sorting this facet by name and by count. Does anyone know how to, just guess how we can do that? Anybody?
So you've got a sort function above that table, right?
Yes. So this is sorted by name. So you can also sort it by count. There we go. Thank you very much for that. So when we sort it by name, you can see that obviously it starts with an A and goes up till the last letter. And then sorted by count, it will show you the scientific name that has the most, or the scientific name that was used the most. I am not going to say these scientific names. Yeah, so that one with 240, that's the one with the highest count, right? So if you hover the mouse on one of the names in the facet list, so let's change it to name. So these look similar, right? But there's one and there's one. But they look similar. Can someone tell me why this and this are not the same thing? What is different?
Somebody must have typed in a space in the wrong place.
That is true. And what we can do is that you can edit. We can add, you can see that there's a space there. We are able to edit. And then when we put it there, so I remove the space, but it's still not the same. I mean, I can see that there's white space also before that, but let's move on. We can fix that. So what you can do is what I just did is try to edit it, or again, you could fix this immediately. OpenRefine will, what you do when you edit, it will ask you if you want to make the same correction to every value it finds, like the one that you saw there. But then again, OpenRefine offers even better ways to find and fix these errors, which we will use instead of individually editing. You saw when I tried to edit, I really didn't get that far. Right. So this is, yes, Jacob, there is double space. Thank you. So facets and large data sets. I mean, this is a large data set. We've got 790 rows. So imagine going through all these scientific names, removing space one by one, making sure that it's not a double letter or there's an extra space in between the letters. We can use, Jacob says I must remove again. Okay. So I'll remove again. There we go. Thank you, Jacob. So you saw that now you did that the first time. It still didn't change it. Doing that the second time. So that would mean you would do that one by one if you actually had to do that for every scientific name. And that is not the whole point of OpenRefine. OpenRefine is here to save us time. It's a superhero that comes in when you need to clean your data, right? So what we use are facets. So facets are intended to group together common values, and then OpenRefine limits the number of values allowed in a single facet to ensure that the software does not perform slowly or run out of memory. All right, so if you create a facet where there are many unique values, the facet created will be very large, and this could result in OpenRefine slowing down, or OpenRefine will actually just not create the facet. All right, so we did one facet, which was scientific name, and we did a text facet with that. So I just did it again, but yes, can remove that one. So now what I want us to do is this exercise. Should take us about 5 minutes. This exercise here, I'll also paste it in the chat. So using facet, I want us to find out how many years are represented in the census, which years have the most and least observations, and is the column formatted as number, date, or text. Please just put your answer below this chunk of exercise. Right. So the questions are in the chat again. So the first question is, using faceting, find out how many years are represented in the census. That's the year column. And then the next one says, which years have the most and least observations? And then the third one asks, is the column formatted as number, date, or text? So I'll give you about 3 minutes to do that. Please just type your answer down here or in the chat, totally up to you. Let me leave it here. I have one answer. Mm-hmm. Let's go. You can label it whichever way you want. Doesn't matter. It's your answer. Go ahead. You can follow the next person. You can make another one if you want. Okay. Okay. 1 minute left, 1 minute left. Right, almost there. Okay, so I have a few answers here. Thank you very much, guys. So for the column here, the question says, find out how many years are represented in the census. So let's try to do that, right? So we go to year, and we do facet, and we do text facet. And find out how many years are represented in the census. We have 16. So 16 is the correct answer. Thank you, guys. And then, which years have the most and least observations, right? So we are going to, will we sort this by name or by account? Anybody? I mean, it's already sorted by name, right? So I think we should sort, thank you, Pamela, sort by count. So when we sort by count, thank you, we find that the one with the most observations is 1978. And the least observations is 1993. Thank you, guys. Yes, everybody got it right. Thank you very much. And then the next question asks, is the column formatted as number, date, or text? And why do you say so? Because we didn't change anything there. Anybody?
I saw it was text because I tried to use the numeric facet, and it said there weren't any numeric values, but it worked when I used a text facet.
The text facet. Thank you. So Open Refine by default. What's this? Exports, imports, yes. Open Refine data by default is formatted as text, right? So if you don't change it to numeric, it is by default text. And that's why these are still text, because we have not changed them, right? So moving on to the next section. as I said, all columns are treated as having text values in Open Refine when it's imported. So we can transform these columns to another data type, which can be date or number, right? And what we use to do that, we use edit cells, right? So we use edit cells and the common transform feature. So then what we're going to do now is we are going to change these, we're going to change some of the columns to numbers and see what other things that we can do with a number or with the format of numbers instead of text, right? So what you're going to do, so let's change year first, right? Go to year, and then we edit cells, then we do common transform, and then we're going to change this to number. I don't like the idea of number, but let's go ahead. Okay. We are going to change that to number. So now everything has been changed to numeric under the year column, right? The next exercise says there are other, the next exercise says the data set included other numeric columns that we will explore in this exercise, period, plot, and that. So transform the columns period, plot, and record ID from text to numbers. And then what you must answer is, how does changing the format change the faceting display in your year column? And can all columns be transformed to numbers? So please just answer that at the bottom here. I will copy this and put it in the chat again for those that don't have the Etherpad open. So on my side, I've already changed year. I've already changed year to numeric. So what we need to do now is change or transform the columns period, plot, and record ID from text to numbers, right? I'm just gonna change this back to text. Right, okay. So that's what we are going to do. And then the question asks, how does changing the format change the faceting display for the year column? This is after transforming columns period, plot, and record ID from text to numbers. Do you see any changes? Unmute yourself, put it in the chat, put in the Etherpad.
Sorry, are we assuming year is still in text format or year format?
Yes.
It's in text format.
Year is still in text format. So I'll give you until 12:05. Color changes to green. Thank you, thank you. Right, are you guys winning? Okay, do we have any answers in? Okay. No technical change, maybe the color. Right. We have that. Let's see. So what we need to do is change period plot and record ID from text to numbers. Record ID. Okay, I'm getting answers. Are you guys also there? Edit cells, comment transform. You change that to number. Okay, and then the next one is plot. Comment transform. Number, and then record ID. Now I've done record ID, period. Right, okay. So the first question, how does changing the format change the faceting display for the year column? No numeric found. Okay, so let's say you facet by text. Still the same, nothing changed. So let's try changing year to numeric also. Let's try that. And then try do a numeric facet. Right. So when I changed year to numeric, I get a histogram when I do a numeric facet of year. And you guys were correct. If year was still text, then there isn't really much of a change observed. Right. That is true. And then the other question is, can all columns be transformed to numbers? Let's see if we have an answer here. Okay. No, the text has to be numeric to be able to be converted to numbers. Correct. So you obviously cannot change scientific name to numbers. Common transform. Right, that's what you get. Nothing will transform to numbers if it actually does not have numbers in the columns. Right. Thank you, everyone. So I think we can take a 10-minute break. If you have any questions, please unmute yourself, put them in the chat, and then we'll take our 10-minute break. So it's 12:07. So 12:17, we'll be back.
Hi, Rafia. We're sorry, while everybody's taking a break, is it possible because I put just a short message in the chat there. Is it possible for us to just dial back a little bit? I'm following on your example, but I've been having an issue. I had downloaded it once, opened it in the browser, running the bat file and so on. And then I tried doing it again because it froze at one of the different functions while you were trying to show your example. And then I tried downloading again without any success. So I'm like not getting anywhere with downloading it again. Is there another way I can get access to OpenRefine? A better way?
Yes, yes, there is another way. I will share the instances that you can use. Angelique, am I at the right line? Where are the instances? There.
27.
Yes.
Okay.
Copy. I'll just put that in the chat. So you can use that. It will automatically just open Refine in your browser.
Okay, thank you so much.
No problem.
Just a reminder, if you leave the browser unattended for 10 minutes, it's going to refresh. So while you're using it, just make sure you are clicking on it maybe every 10 minutes, okay?
Okay,
Everybody
thank you.
got that? Thanks.
Hi, sorry, Rafael, while we're waiting for everybody else, just a quick question. Okay, thanks for the link. I did manage to now open it through that link. But compared to your screen, in terms of cleaning up for the record ID, because I think I missed that part where you guys cleaned up for the record ID, because some of the record IDs are just the 4-digit numbers, and the rest of them, it takes the whole, CSV type text.
Sorry, I didn't get that. Some of the record ID.
So some of the record IDs in the file that I've got when I create the project and I get to this screen of facet filters, I then see a whole lot of record IDs with the 4-digit numbers, but then I also see some record IDs with a whole lot of text next to it. So let me just go back to that screen. Yeah, so it's got like
You
6, 5. Sorry, go for it.
You want to share your screen?
Yeah, okay. Okay. Should come up now. So this section up here.
Record ID 6AB. Okay, so what happened there, as you can see, it did not separate it properly. So I'm going to go back. So when you see custom, but it shouldn't do that to you really. Let me just check something. There must be something, because it's supposed to be comma and yours are, I do see comma. Let me just go back to my one quickly.
Okay.
And see what is different. But it's probably just.
Is there space before the semicolon by custom?
No, there's no space on his one.
Okay, sorry. For some reason, it looked that way from my end.
I think ours didn't have the custom as semicolon. That's why.
Yeah, just take the semicolon out.
Let's take it out. Okay, and then let's go back there.
Sorry, let me just close this for myself. So you have a CSV, and then please wait for me. Just uploading again. Just want to show you something. Right. So for some reason, even though you didn't, because it says CSV, character encoding. That's the thing. Your character encoding is Windows 1252. Ours is UTF-8. Does anyone else remember what their character coding was, and if it's the same as mine or Yatil's one?
Can you just go and change the character coding to and see what happens?
I've never come across that in my life. And then go down to your, so in your preview at the bottom, so the top one says ignore first, unclick that one, uncheck that one. Right. And then let's just go to custom. Put a comma. Update preview. So Jacob also has UTF-8. Yours has Windows 1252. I have not encountered that before. Tajuddin, Angelique, the helpers, have you come across this before?
No, but can you change that character encoding? You can write it manually.
Okay, let's try. Let's try right.
The character encoding. They have UTF-8.
Let's try type it in manually. So there, I put it in the chat. UTF-8.
There where it says character encoding.
Let's open another page.
By character
encoding. This one, you can go up. Let him open another fresh page. And load the data again.
So I should start over.
So
go to that.
Mm-hmm.
Go to the link and open it again. So you have two open
Just
refines.
Go up.
Okay.
Up this cell. You will see open file. Open the file again. It will bring in another menu for you to apply the something back. Maybe I can share my screen with you.
Okay, yeah, let me stop sharing quickly.
Yes, who's sharing screen now?
I think Tajudeen is going to.
I will just say I want to see where I want to put him through. I'm sorry, let me just quickly do that and come back.
All right.
Hello, let me share my screen with you now. Can you see? Is it sharing now?
Yes.
Hello?
Yes.
Okay. So
Yes, we can.
this is the screen I open. You will see open here at this end. You see open, export, and help. So just click on open. Give you another screen entirely. Then you can load.
So you can choose file again.
You can load it again to restart. So you don't need to close the other one. If you want to use it, since it's just opening at the menu, you read the file next again, then it will run. You will see it immediately. The character encoding should be UTF.
UTF-8,
Yeah?
yes.
8, UTF-8. So if it's not changing there, you can change it on your own. You see the open here. These are the characters there. Can you see? Click on it. Just click on that side. You see all the character encoding there. You see why ISO 8858. You see that one. US hashing, UTF-16, and others. Just click on it. On the character encoding there. Hello, have you seen that? Click on the character encoding box there. It will bring out all the character encoding. Just change it to UTF.
UTF-8.
So can you see my screen?
Yes, yeah, perfect. Okay, I'm gonna try it out now. Thank you so much.
Okay. Please let us know once you're done with that, so we don't leave you. Right, so let me. Okay, so then let me reshare my screen. And is everybody following? We are at the same stage again. Is my screen visible?
Okay.
Awesome. So, thank you. So I closed and started again. So I need to change my record ID to number, year to number. What else we change? Period. We also change period to numeric. And then we facet there. So we have our histogram, right? So we are just jumping into an exercise. And then, so we have 2 more exercises to do. So just 2 more things, and then we will be done for the day. If you have any questions after that, please just do let us know. So the next exercise says, the next exercise, gone. Right. For one of the columns that you've transformed to numbers, edit 1 or 2 cells. Replace the numbers with text, ABC, ZBD, whatever, or a blank, right? And then what you're going to do is you're going to use the pull down menu to apply numeric facet to the column that you've edited. This facet will appear in the left panel, right? And then notice that there are several checkboxes in the facet, which is numeric, non-numeric, blank or error. And then below those are counts of the number of cells, and you should see checks for non-numeric and blank if you change some values, right? So then we're basically just playing with the data here. So I'm gonna give you about, we'll go until 12:30 with that. If you wanna share your screen while you're doing that, go ahead. If you have any questions, let us know. So yeah, we can start with that. So we're using one of the columns that we have changed to numeric already. So I've just put that in the chat. Right. So one of my columns that I've changed to numeric, I mean, we should all have the same one, right? I'll go with period. So you can edit 1 or 2 cells. I'm going to edit there. I'm going to put right. Is everybody else getting the same?
Yes.
The same error?
Yes.
Right. So what we do, edit data type, we change that to text. And then we can change that to whatever, ABC. Then you apply. So I've already done that for 2 cells. Everybody else, you can have a field day and do more if you want. Right, so I've done 3. Are we all there? So then the next instruction says, use the pull down menu to apply a numeric facet to the same column. Right, so we go facet and we apply numeric facet. Right, so once you've done that, so I did a facet for period, then the facet appears on your left, on the left panel. So what you see there now are different checkboxes, which we don't have for year, because remember, year was now changed to numeric and everything was numeric. But now in period, some of the cells are text and majority of them are numeric. So when you facet that by numeric, what you get are 4 checkboxes. We have numeric, non-numeric, we have blank and error. So what it's showing us is that numeric, we have 787 counts of numeric and 3 non-numeric. We have no blanks and none are in error, right? So what we're going to do now is just play with the data, see if you click. So if I click on blank, nothing shows. If I take out the non-numeric, it took out some of the data. So there. So we have numeric. I've clicked nothing, so there's obviously no data. So if we click on non-numeric, we can see that for period, there are 3 that are non-numeric because those are the 3 cells that I changed. If we remove that and click on blank, there's nothing. We have no blanks. Click on numeric, it only shows us the 787 counts of period that we have, right? So when I click that, it shows all of them, even the one that I have edited to text. Everybody had fun playing with the data? Is it showing, or is it clear now how easy it is to manipulate or wrangle our data using OpenRefine, the facet, and how you can change them to numeric and to text? Anybody who's lost or left behind? We shall leave nobody behind. Everybody good? Thumbs up, please. Or unmute yourself. One thumbs up, 2, nothing, somebody.
We had 5 in the chat.
Okay, awesome. So what we are going to do next is we are going to examine a pair of numeric columns using scatter plots. I don't know if you noticed when we were doing facet, you can have Peter, your hand is up. You may
Yeah,
speak.
I also ask something like now we've changed there under period those observation as from numeric to text. So let's say now you want to really return them back to the actual number. The OpenRefine does not have undo, so it means you need to know what to change.
Right. So on your left panel, thank you for that question, Peter. On your left side panel at the top, you have undo and redo. So if I undo, it will show you all the things that I've done. So obviously mine are, there's only 6 because I restarted, right? So you guys should probably have more, but you can click on what you want to undo. See as I'm there. So everything is back to what it was. Or you can redo. Right. That's what I meant by the nice thing about OpenRefine is that you are able to undo what you've done faster than you can say, I made a mess. Right. So there it is. Does that answer your question, Peter?
Yes, it does. No, thanks.
Awesome. Thank you so much for asking that question. Very important question. Okay, so there we go. Everything is back. So now what we're going to do is we're going to examine a pair of numeric columns using scatter plots. So if we look at year, I don't know if you noticed this, but when we did facet, remember with year we had done text facet, then we did numeric facet. We actually have other types of facets. We have timeline facet and scatter plot facet. So what we're going to do now is we are going to explore the scatter plot facet, right? So we do have multiple columns that we have changed to numeric, right? And we had to change them to numeric because the default import into OpenRefine is a text file or text format, I should say. So now what we want to do is yes. Hello. Okay. So what we are going to do now is we're going to select one of the columns that is in numeric format. For example, record ID. However, our record ID, no, is it record ID? Oh, sorry, I changed period, not record ID. For anybody who changed the cells in record ID, please just undo them and change them back to numeric, right? So let's say record ID. So what we're going to do there is we are going to explore the scatter plot facet using record ID. And so what we do is facet and scatter plot facet, right? So what's going to happen is we're going to get a new window on our left. Well, okay, mine is not in the left panel. I have a huge one right here. Does anyone, maybe it's the older version that still showed us in the left panel. But anyway, so we get a scatter plot matrix for record ID, right? So what we see here, we have windows or little scatter plots for record ID, year, and then we have period there. I'm worried because my period has text, but let's see, right. So now these squares, there's a pair of each numeric column and it's organized in the upper right triangle there. So you can see that each square has the scatter plot and then these show obviously what that column is representing. Did everybody get one of these?
Yes.
Everybody? So, sorry, let me just go back. I did something there without explaining what I was doing. So facet, scatter facet. So you have record ID, and then we have year and period. And as I said, my period might look different to yours because I have text in my period column that I have not changed, right? So what we want to do now is click the image of the scatter plot between record ID and year, which is that one. So I get that. Okay, so move to that. Our next exercise, it says, so everybody has the scatter plot on their screen, right? If you don't have your scatter plot yet, please just let me know. Okay, so the exercise says, click in the scatter plot facet in the lower left margin and drag to highlight a rectangle. How does this change the data rows displayed? Okay, I'll give you 2 minutes to do that. I'm assuming that everybody has their scatter plot on their screen. Please write your answer in the Etherpad or unmute yourself. Okay. Any questions? Everybody okay? And I'd like to get one volunteer to share their screen to show us what they did in this exercise. Don't mind me, I'm just editing, transforming myself. Any questions? Everybody okay? A brave one wants to share their screen and show us how they did this. Any takers? So it says, anybody?
Okay, I'm trying to share my screen. Can you see it?
Not yet. Let me stop sharing. Okay.
Can you see the right thing on the screen?
We are seeing instructions. We're seeing your sticky notes.
Stickies.
We're seeing your
okay.
sticky notes.
Okay, let's try again.
Okay. You're seeing a nice background.
All right. Can you see it now? No? Hang on.
Yeah.
All right. Now you can see it.
Yes,
Right?
now we can see it.
Okay. So that's, come on.
Maybe move it to the middle of the screen
Yeah,
a bit.
I'm getting there.
Okay.
All right.
Awesome. Yes.
All right. So as you highlight different parts of the data, what is it changes the rows that are displayed according to what you've highlighted.
Yes. Yes. Definitely. Thank you very much for that. Does everyone get the same?
Yes.
Oh,
Yes.
awesome. Thank you. That's great. Thank you very much, James, for showing everybody what you're seeing.
It's a pleasure.
I'm glad that everybody is following. And also you can double click on each square to add comments. Oh my gosh, I've been muted this whole time. I'm so sorry. So I was saying that we will end our lesson here today. It's about 18 minutes earlier than the time scheduled, but that's okay. So we'll continue tomorrow with transforming data in OpenRefine. I have put a link in the chat for if you want to explore more of the facets that you can use or how you can use the faceting in OpenRefine. We will go over it again tomorrow before we get into the transforming of data. So yeah, and I just wanted to ask Angelique if there's anything you want to add, Tajuddin, before everybody drops off.
Nothing from my end. I would just like to encourage participants to please complete the sticky notes for us. It will give us just an idea, are we going too quick, are we going too fast, is there something that's unclear, so we can just adjust our teaching style a bit to make it a bit more learningful, I don't think that's the English word, experience, and maybe something, yeah, Rafael, I don't know. I haven't had coffee yet today. I need more coffee. But thank you, everyone. From me, that's it. Thank you, Rafael, and I'll see the rest of you on Wednesday again.
Awesome. Tajuddin, you want to add anything? Okay.
I just want to at least, I mean, the student to keep on learning, because learning is not restricted to age or class. You could just continue to learn and practice a lot about it. Thank you.
Thank you, Angelique. Thank you, Tajuddin. So tomorrow, instructors will be myself and Tajuddin. So we're going to do the rest of Open Refine, and then we are going to start with some of the R. So see you tomorrow, guys. 9 a.m. sharp. Thank you.
Hi.
Sorry.
See you, everyone.
Kindly download R and R Studio tomorrow, before tomorrow.
Yes.
Download it
Please
on time.
download.
So that the link is there. I've placed the link of R and also there an R Studio at the header pad. You can see it there.
Yes, the links are in the Etherpad, but I can put them here for those who are still here. If you have any questions, you're stuck with downloading R Studio, maybe you can log in at 8:30 tomorrow, and then we can assist you if there's something that we need to assist you with. So we'll be on the call 8:30 tomorrow. Thank you, everyone.